Hello, everybody. A warm welcome from Berlin. Today, we want to talk about Instana Turbonomic and what it has to do together with the Cloud Pack for Watson AIOps. But before we go into the topics, I'd like to have a short introduction round. My name is Fred Klein. I'm located in Berlin. I'm technical lead of the SWAT team. And today I have 3 colleagues with me, and I'd like to hand over to Henning to introduce himself.
Thank you, Fred. My name is Henning Sternkicker, already listed here on the slide. I'm located in the western part of Germany, on the other side of Germany, so to speak, from Berlin's perspective, working in the DACH market for the so-called enterprise containers team. So everything around container orchestration, plus also the operations perspective with Watson AIOps is within my technical view. So over to you, Frank.
Thanks, Henning. My name is Frank Wickert. I'm a sales engineer with Turbonomic. I'm based in Frankfurt and I'm covering the DACH market. So, and I'm handing over to Peter.
Hello, everyone. Thanks for having me. My name is Peter Jüntgen. I'm working as a solution architect at Instana, and I'm heading the technical sales team here at Instana for EMEA. And yeah, great to meet you and great to have the ability to talk about Instana. So then I suggest to jump directly into a demo of Instana. Let me quickly share my screen. Let's start with a quick Instana introduction. So Instana is an observability platform. And the idea that I have brought for today is I have here a Kubernetes cluster, and this is a 3-node Kubernetes cluster. And on this Kubernetes cluster, I have deployed an application, a demo application. It's called Robot Shop. And let me quickly show you what's been deployed here. Here you can see the basic Kubernetes system. So I've just started this 7 minutes ago. And then a few minutes later, I've deployed Robot Shop here into this Robot Shop namespace. This is currently what's running. And now the challenge is to have observability in the setup. And with Instana, and here I've just started a SWAT demo environment, it's pretty easy to do this. When you log into Instana and you have nothing that is currently monitored, Instana automatically suggests you the different options that we're having for deploying Instana to this cluster. So here we have all these hyperscalers. We have, for example, vanilla Kubernetes. We have different other operating systems. And whatever you pick, for example, in this case, Kubernetes, we come with a variety of options how you can deploy Instana into that environment. So in this case, for example, for Kubernetes, I can just run this Helm chart command. It's a one-liner, so it's not that interesting. So let's quickly take the YAML file and give the cluster where we want to deploy Instana just a name. Let's call that SWAT demo as a name. What I can do, I can download now a YAML file for this configuration. So let's quickly download this. Let's put this into my downloads folder. And so it already exists. So let's override this. There we go. There's my configuration file. And the only thing that I need to do to deploy Instana to my Kubernetes cluster here is I just run kubectl apply. I specify a file name. It's in my downloads folder. And here it's called configuration YAML. And that's it. So what I've done now, this pre-configured configuration YAML file that I've just downloaded is now applied to my Kubernetes cluster. And you can see what is being created. We create a namespace for Instana, we create service accounts, we create configurations and so on. And that's all that you need to do. When I run this kubectl get pods all namespaces again, what you will see is, we still have our kube system, we still have a robot shop. And in addition to this, we have Instana agents. These Instana agents have been deployed. They are running, so since 21 seconds here. And now the Instana agents are updating themselves. They are starting to download specific sensor depending on the technology, and they will automatically begin to collect information. Going back to Instana, what we can do, we can click on this Instana agent YAML file, and then you can see what really is specified in this. So here, all the configuration is set. You have a cluster name and you have a configuration YAML file, which is mounted as config map. So here, when you need to apply specific settings, you can do this. The challenge or the approach that Instana is following, we try to do whatever is possible. We try to do it automatically. So you really it should only be required to make minor adjustments to this configuration file. So as mentioned earlier, now what happens, the Instana agents are starting, the Instana agents are updating themselves, and the Instana agents start downloading specific sensors. And here, when I click to go to Instana, I can avoid having this specific configuration screen. And what Instana will monitor, it will monitor the infrastructure. We will see this in a moment. So we will monitor hosts and all the components running on these hosts. Instana will monitor the Kubernetes cluster and the platform, as well as the applications. So Instana will, wherever possible, automatically enable tracing, and you can see all the individual traces in Instana. Let's start with Kubernetes. So when I click on Kubernetes, currently you see, okay, nothing is here. So we need to give it another, 1 minute. Okay, now let's take a look at all the different areas in Instana. First, infrastructure. What you can see here, Instana has up to now detected 2 nodes, and 2 nodes, they are running specific or individual Docker containers. Here on the left-hand side, you can see some changes. So what Instana does, Instana starts. Instana is automatically detecting all the technologies that are in use on this specific component. And here you can see that these generic Docker containers, they change to a higher order technology, like a Node.js application, like a Redis, like a RabbitMQ, and so on. And this process is done automatically by Instana initially and continuously, which means whenever something changes, Instana is aware of these changes. Currently, we have 2 nodes. The 3rd node is currently, the Instana agent is starting up, so we will see this in a moment. This is the infrastructure. In addition to this, what you can see on the left-hand side, you can see the Kubernetes area. So the Instana agents have detected they are running in Kubernetes, obviously. So one of the Instana agents is pulling information from the Kubernetes masters. In this case, we have specified a name, it was called SWAT demo. You see some KPIs of this. I can click on this, then you see the details. Here the metrics start from the point in time when we have deployed Instana. So we have plenty of information regarding this Kubernetes, in this specific case, GKE cluster. And here you can drill down, for example, to all the pods that are being deployed on the system. Here, for example, we have the robot shop pod. I can open this pod. I can drill deeper into this, and I can see specific details. And this goes to a detail level where we even have the spec. And this is the spec for this specific Kubernetes pod. In Instana, we are always showing you context. So in this case, you know, this specific Kubernetes pod is running as, or in this deployment, in this namespace, in this specific cluster. And when you click on this Kubernetes icon here, you can see all the clusters where you have deployed Instana. This is the infrastructure, this is Kubernetes, and in addition to this, we are providing application monitoring, which is tracing. So here, when I click on this applications view, you can specify your own views. We call this application perspective. So you can really specify in a very granular way which kind of calls, which kind of infrastructure you want to see. The application perspective that we are shipping out of the box is all services. It contains 5 services. And when I click on this all services, you can see now relevant KPIs that specify service quality. So in this case, very simplistic demo application. In the last 10 minutes, we had 359 calls. 16 of them were erroneous, which is 4.45%, and a mean latency of 9 milliseconds. And I don't want to click through all of these details, but we have plenty of metrics. And this is something that Instana automatically creates. It calls the dynamic dependency graph. So Instana understands what service is talking to what other service. And Instana understands dependencies by this. You see some particles flying here. The particles indicate how frequently service is called. And if there are some red particles, you know that there's a specific error rate. And the point or the origin where we get this information from, Instana is tracing 100% of all the inbound and outbound calls. So when somebody has used the service here that we are tracing, we have a distributed trace for this. So what I can do now, I can go to Analyze Calls. When I click on Analyze Calls, we jump into Instana Analytics, indicated here by this magnifying glass. Instana knows we are coming from this all services application perspective. Instana automatically groups this in a logical way. So in this case, it says it makes sense to group them by services. And Here in this case, for example, I can just remove the grouping, and then here on the bottom we can see each and every individual trace. And when I order them by latency, for example, here we have a request. It took 1 millisecond. At this point in time was a GET request to this URL. I can open this, and then we see a distributed trace what was going on for this. In this case here, there was an HTTP request, and this has made a GET request from Redis cache. So this is what Instana provides out of the box. The idea is to automate wherever possible, to have a very high resolution of the data. So all the metrics that Instana is having, let me open the dashboard again. So hopefully you can see this here, the metrics are moving. This data here entering in the system are 5 seconds old, so very recent data. And the resolution of these metrics is 1 second. Very high data granularity. We trace 100% of all the traces. The next thing that I want to talk about is context. Let me pick an application. For example, here I want to take a look at a specific Node.js application, this catalog application. When I open the dashboard, you can see here the metrics are moving. The data entering here on the right-hand side is 5 seconds old. And the resolution of this data is 1 second. So very high granularity of data. We have 100% of all the traces, meaning inbound and inbound calls. This is super relevant because once you have an issue, you want to make sure that you have the data. And Instana is providing context for all of these views. Having said this, now we have deployed Instana to this GKE cluster. So now we have full observability into the systems. And of course, this observability can be used by several different other systems. Now I will hand over to Frank.
Thank you, Peter. So now it's on the point to talk about Turbonomic and how Turbonomic fits into the play. So I have a small agenda for you. I have only a 1-slide introduction to Turbonomic to highly explain what problems we are solving. And then I step immediately into a live demo, because what you can see live is always better than a presentation and slides. Everybody can paint nice slides. With that, I'm going on with my 1 slide and talk about the common problem we see in the industry. The problem is that everything is taken care about the application. The application is the most important part in our world, and for our customer, the application is key. Why is it so? Because application availability, performance, response times, also the avoidance of risk is essential for the end user experience, the loyalty of the customers, the revenue, and so on and so on. Effectivity is also very important, but you can optimize your system only if you know what is the performance demand of the application. Only then you can size the system accordingly and save maybe some money on that. But who allows all this to run? This is, at the end of the day, the shared infrastructure. And here we are talking about server infrastructure, network infrastructure. We have the virtualization infrastructure, cloud, storage, container, and we have all the teams taking care of these different problems with their own tools, with their own teams, with their own databases. And how are these monitoring tools are working? At the end of the day, these tools are working in the moment when the application is not assured anymore. Then an alarm pops up or an event pops up, whatever. And depending on the noise you always have, maybe you ignore it, or if you don't ignore it, then immediately you start looking for it, and every entity or every team is looking independently for the solution of this problem. Even harder, the whole thing is coming when a customer calls or an application owner is calling and tells you, my application is slow, please help. Then immediately every team is starting to investigate their monitoring tools and find out what's going wrong. So at the end of the day, this is an industry problem, I would say. Our monitoring tools are looking for performance or response times only if something goes wrong. And then we are taking actions. And I will show you later on in the demo what is the different purpose, what we are doing with Turbonomic. So what makes it even worse is that the application demand is changing all the time. So all the applications you have are changing regarding their demand. And this is depending on the time of day, the growing of the application. So there are several reasons why these different applications are changing all the time. But who's caring about the shared infrastructure? so that the shared infrastructure is fulfilling the needs for the application. At the end of the day, nobody. It takes as long as an alarm pops up, and then we're looking for this whole thing. What makes it even worse is when I look back in time, the components are changing from my one-time physical servers to the virtual world, to the cloud, to the container later on. So when I see that in the containerized world, we have about 500 to 800 times more components we need to manage than we had in the physical or in the virtual world. The next thing is the release cadence. Back in the days, we had the annual or biannual release cadence. Now it's up to daily releases or even real-time releases, depending on how far you are with your containerized environment. The next thing is the people you are talking to. In the good old days, you had your IT ops, but now you're getting up to the chain. You're talking to the DevOps people, you're talking also to the line of business people, and everybody has something to do with performance and response time in this case. And last but not least, the number of management tools. The number of tools every team is using is growing exponentially. The more components you have, the more tools you have, and this multiplied by the number of teams tells you how many tools you have and to find out what's going wrong in my infrastructure. What could help in here? At the end of the day, the whole system is based on demand and supply. So the application is demanding for some resources and the infrastructure supplies these kind of resources. That sounds easy, but it isn't as easy because at the end of the day, it's a little bit like a stacked demand and resource. So for example, the application is looking for more demand than the virtual machine, for example, or the container is giving more resources to the application. But on the other hand, the container or the virtual machine is asking the physical host to get more resources to fulfill the demand. And the physical host is asking for the storage to give more resources to fulfill the needs. So at the end of the day, what Turbonomic is doing, every entity makes its decision on its own, only looking on demand, what's coming from the higher stack, down to supply, what they can supply, and what they need from below. So that's the basic what we're doing with Turbonomic. I will show you later in the demonstration how many actions are necessary to fulfill these things. And this leads later on to the question, how far are we going to automate this? So automation is one of the big things. So far, when you install Turbonomic, it is a manual process. So everything is set to manual. We tell you all the different actions you can take, and you decide how to take it, when to take it, all this kind of stuff. Once you come to the point that you trust the system because you have seen the actions, what we give to you are right and improving the performance and make the whole system more stable, then you have the chance to do this half manual or manual. So there are different grades you can choose. And at the end of the day, this is the supply chain, what we are showing to you after all. So we're showing you all the different components from the APM systems, for example, like Instana, but also other ones like Dynatrace, AppDynamics, New Relic, whatever. You also see all the container environments, you see the virtual machine, you see the host, you see the storage, and the example what you see over here is a very small thing. This could also include cloud, for example, and I will show you later in the demo, or more or less directly in the demo, how this is working. What you need to know about this is no agents, no configuration, only data via the APIs. So that's all we do. All this creation of this supply chain map, this is what we are doing for you. So this could be your infrastructure. And within 60 minutes after installation, we have this map on the screen and you can see the first actions popping up. So with that, I would go to the demo and show you a little bit more about how these things are looking. So what you see in here is our home screen, I would say. And immediately you see on the left-hand side what we call the supply chain. As already said, this supply chain is a little bit bigger than the one in the example. What you see in here, for example, we have 48 applications. We have the transactions, the services, and the application components, which at the end of the day makes the application. We get this information regarding the performance of the application from APM tools like Instana, for example. A little bit down below, then you can see the containers. Here we have 693 containers in 462 container pods. We have all the different container specs and the workloads, and we have the virtual machines down below, about 1,000 in this example. A little bit down, we see the physical host, we see the data stores, we see the storage, and this all is going down to the cloud at the end of the day. This is a picture of your hybrid environment as it exists in your environment, for example. We can divide into the application. Here we can see the hybrid way, but we can also see only the on-prem view or also the cloud view. We will see later in detail. This is cool, I think. So when I saw this first time, I thought, "Ooh, this is a cool thing." But if this would be everything, this wouldn't be the really cool thing, because the really cool thing is what happens now if a customer calls you and say, "My application is down or it's bad, has a bad response time." So what you need to do, and you see here my top business applications, the only thing you need to know, and if to put the pictures a little bit higher. So now you can see, show me all the applications I have in my system. And because we are talking already about RobotShop, I have a RobotShop instance running as well. So what we can see now, we can go to RobotShop, and immediately we see all the components which makes up my RobotShop application. In here, you see my application, transaction, service, components. And again, we have a container environment, we have virtual machines running on storage. So this is my RobotShop application. The next thing what you can see is we have these things, for example, by the way, we see all the response time of the application because we get this information from Instana. By the way, you can see that it's getting from Instana because we have these small little logos over on the left-hand side, and this is now coming from Instana. And in here, we can see all the business transactions and we get all these kind of information. But what makes us really unique is we have the possibility now to see the actions which we would provide to get a better performance or maybe some enhancements in the infrastructure. And this is how it looks like. So here we see our action center. We see a lot of actions, what we can do. So let me skip to the resize actions, for example, the virtual machines. So go over here. So now we see that we have 3 suggestions or 3 actions. And these 3 actions tells us we need to upsize the vMemory from 512 megabyte to 1.5 gigabyte. The action category, and now we're coming back again to the point, performance is the key thing. So to assure the performance of the application is always #1 goal. Reduce the risk and ensure the performance. I will show you later on some effectivity actions. But in here, so this is a performance action. We can go to detail. When we go to detail, we see, we need to resize up the vMemory from the virtual machine X from 512 to 1.5 gig. Why? Because we are running at 97% over 95% of the time over a 30-day observation period. And this means from 97%, which is way too high, we are going to bring down this to 32%. And this means we have a capacity of 1.5. And here you can see, once you would do this kind of action or take this kind of action, here you can see automatically where the usage of the vMan in this case would lie. What you can see over here, the action can be accepted and executed immediately, and you can do the action right from this screen. Of course, you need to know a little bit what actions can I do online, what does not hurt anything. If there is something, we have this concept of constraints and policies. So we can give all the policies, for example, if this action would need VM to shut down and restart again, that we can only do this on a Saturday in a 3-hour change window or whatever. So this is done to ensure that nobody can do any damage on it. Of course, this execute action, which is now manual, can be done automatically as well. So this is, at the end of the day, this is the primary goal. When I step back to my main picture, here you can see now how many actions are we talking about. When I show you all the actions, we can see that we have about 2,700 actions in this environment, what we're looking for. 1,800 on-prem, 443 in the cloud, and in the container platform, again, 253. All these actions could maybe be done automatically, and this would keep your system always in a thing what we call desired state. So we are looking, for example, for all the virtual machines or for the physical host, that they are proceeding in a predefined desired state. This could be, for example, a 70% usage, because this is the sweet spot compared to usage on one side and response time on the other side. And whenever we're changing from 70 to 80, we are looking to get the usage back to 70. Same thing happens if we're going from 70 to 50. The system is always trying to get back into this window of our sweet spot to operate in the best possible way. Think about how your system would run if these effectivity things and these performance things would have done automatically. You can always go back via this green button and you see again all the applications. Sometimes the question comes up, but what happens if I have applications which are not covered by an APM system? Pretty easy. Here I have created my own application, so I can see my own application. I can see what components make this application. And again, I can see all the actions which are necessary to take to assure the application of the system. The system is a little bit slow today, but here you can see we have different virtual machines, and 4 of them have performance problems, and again 4 have effectivity things we can change. And again, if you go to the details, you get all the information what you need to do, upsize or downsize. So this is really, really pretty easy. Another thing which is important is we have the possibility to do some planning over here. So for example, when we look for a plan, we could look for example for on-prem optimization. So this is now something we are asking the system, dear system, please tell me what would happen if the following actions would be executed, or what if the certain guardrails are executed. What we see in here, in this case, we have a container infrastructure with container pods. So 95 containers, 91 container pods, 448 virtual machine running on 9 hosts and 5 storages. So, and after doing the plan, we would reduce this, for example, to 7 hosts. And over here, you see all the different changes which could save money at this point in time. For doing that, we have actions which are 651 actions which are needed to come to this desired state. So this is pretty obvious. Once you decide to go that way, you can set these constraints and you can set these policies in your system, and this will done automatically, and you will get to the point that you reach these benefits, what you see over here. Another plan could be, for example, migrate to the cloud. In here, we would see what would be the result if we do a lift and shift action directly. So here we would see we have 47 out of 191 applications which have some performance risk. We have virtual machines with effectivity problems, 144 out of 191. And if we would move these machines like they are to the cloud, we would have cloud costs of about $45,000 a month. When we optimize the applications before, we reduce or we eliminate the performance risk and the machine efficiency problems. And my costs at the end of the day are going down, in this case, only to $41,000. So nevertheless, this is the way how we going for these kind of plans, optimize the application and then move it to the cloud is a much better way than moving it to the cloud first, buying machines, buying reserved instances, and then figure out that the costs are too high. So last thing I would like to, no, not the last thing, maybe the second last thing. For example, if you search, in this case, you search for a cluster. And now we see that we have several clusters, and these are marked red, yellow, and green. And when we go for this Hawthorne Thales cluster, Then we get some information regarding this cluster. And again, we see the health of the cluster and we see the different machines which are used by this cluster. And we can step a little bit ahead to go to an example I know, which is very healthy. So we go to number 4 out of 10. In here now, we see a cluster which consists of 9 machines at this point in time before we are taking these actions. After we are taking these actions, we can remove one of the machines out of the calculation. So we still have, we only have 8. Here we see directly the actions necessary. We get the list of hosts, we get all the details, and we can define the policies, when to do it and how to do it. So last but not least, I'm going back to the main screen. And now I'm showing you an example of the cloud management. Cloud management, when people talking about cloud, the first thing everybody is telling, my bill is too high. We need to cut down the bill. And the answer could be, yes, not a problem. Go down to the smallest machine and you cut down your bill dramatically. Yeah, but the answer is, if you're doing that, the performance is bad. And this is exactly the point. We are not talking about a bill problem. We are talking about a performance problem. And what we do, we are looking for the performance of the application in the cloud. We are looking, is the performance and the response time of the application in the cloud good enough, or do we have to do some investments, necessary investments, to get this application to the state we want them to be? So what you see in here, there are necessary investments of $575 monthly, and we could show all of them. Here we can see we need to scale up virtual machines, we need to provision new machines, scale volumes. So this is the thing that we say you need to invest more to get to the desired performance. On the other hand, of course, we have these potential savings. And as usual, the number is very, very much bigger than the investments, about 7,000 euro in this example. And when I go down to the details of this whole thing, and I'm going to the volumes, for example, now you can see, hopefully in a second, now you can see what we would suggest, what you should do. So we have scale actions about 166, which brings savings of about 1,632. And just to show you a little bit about, for example, this one would tell you, you should go from a standard tier with 8 gig disk size and 160 IOPS, which costs $47 a month, to a GP3 8 gig disk size again, but now with 3,000 IOPS. And this costs you about 48 cents a month. So at the end of the day, this brings you more performance. This is a performance action at the end of the day, but it also reduces your cost. So, and the charm of the whole thing is, this can be done non-disruptive. You can do this directly, and it's reversible. You can go back. If it's not non-disruptive, we tell you it's not non-disruptive. But in here, how could somebody not think about doing this? A much better performance for a much lower cost. At the end of the day, this is what I wanted to show you, because I'm running over with my presentation and with my demo. And with that, I would like to hand over to Henning to wrap up the whole thing. Thank you very much for the attention.
Okay, so let me take over from this demo parts that we have seen with Peter and Frank. Thank you for that. And let's wrap it up a little bit. We have seen Instana and Turbonomic, and I always appreciate to say that it's better working together. So Instana and Turbonomic, and I hope that we will see in the end that it's also working together better with Watson AIOps. But for now, what have you seen so far? We have seen so far that Instana and Turbonomic is caring about the application performance, assuring the application performance from a perspective of application performance management, observability, Instana, and application resource management with Turbonomic. I see that in that way that it's the same problem from two different sides. With Instana, you have the complete observability, the full stack, automated discovery of everything in real time. And with Turbonomic, you have the same visibility of the complete stack, but from the resource side of view, and especially from the resource dependencies point of view. With Instana, together with the observability, you have also the capability of analyzing the anomalies that you are detecting down to the line of code. Peter has shown that you really can go see where does the congestion happen and why. Turbonomic is there for making the resourcing decisions that we can get over such congestions in an automated way. And both are, in the end, your tools for continuously optimize the application. Instana, from the real questions of why and how is something happening, and Turbonomic bringing you the capabilities of really automating your decisions so that you can operate just like an autopilot in those boundaries that you put around your applications. So that is what I would say the best possible way of handling and assuring your application performance with these tools. But, and I have to say but, because that it's maybe a little bit more complex work, because Instana and Turbonomic are working on this application performance really on metrics data that they are getting and that they are correlating and that they are automating with. But there are more data that we are getting, and that is where Watson AIOps comes into the play. It's good to have Instana on this observability side, to have this metric-based insights, no blind spots. It's good to have these analytics capabilities of Instana and Turbonomic together to work on this structured data, on this metrics data. And it's good to have Turbonomic, where we can do some resourcing automation decisions and do the things of handling CPU related or memory related or storage related resource scaling actions on that. But there's a little bit more on that. We have, as I said, not only the structured data, we have together with all the data that we are collecting, also the unstructured data. And that is especially where we need something in addition, Watson AIOps, to bring that also into the play and to give this really, as we see it here, as a closed feedback loop where all these tools work together. And how Watson AIOps fits into the complete picture, I will quickly show you over in the next minutes. So what is Watson AIOps? In the end, as I said already, it's a cohesive, comprehensive solution that not only is working on structured data like metrics that we have already seen, how Instana is handling that, on topology data, on events and alerts, but it's also working on unstructured data, logs and tickets that have also relevant information. And that is the basis for a combined and cohesive view on. That is where Watson AIOps brings all these things together and stitches all these things together. That means we have the different, let's say here, managers that bring in all these kind of data. Event manager, we dig a little bit deeper into that later on. The metric manager, topology manager. And on top of that, we have the AI manager that brings this all together, works on all these data with our analytics, machine learning, and artificial intelligence capabilities, and combines them and present them in an easy to use and easy to understand interface that we are using here at ChatOps for presenting all the correlated data together. From that, you can navigate down to each of the needed tools for having a deeper look at. You have always the capability to analyze further from that. But the first thing is that Watson AIOps really gives the comprehensive overlook of all the different data that we are collecting. Let's quickly go through the different types of data we are working on. Let's start with the metric manager. The metric manager is collecting the structured data metrics from different tooling. And that is where you do not have to start with new systems, where you can integrate into the metric manager your tools that you are already using. Could be Instana, could be any other data collecting tool that you are already using. And with the metric manager, we bring algorithms with where the systems, the metric manager is learning from what is the normal behavior. We do not have static thresholds. We have a dynamic baseline where we compare the actual performance of the different systems to what the metric manager has learned from the past and is able to see what is different from the normal behavior. That is one thing. We can also detect what are the systems that are currently have variable usage that is now flattening And in addition, we have also the capabilities of learning how the different metrics have a causal relationship. Some metrics are going up and breaking some thresholds. When does this correlate with other metrics going down? The good thing is that this is working on your existing tools, it's working on your existing data, there's no training needed. It's learning from observing your metrics that are coming in and then giving you the capabilities of seeing what is beyond this baseline. So that was the metric manager in a glance. Then we have the event manager. That is getting all the alerts coming from systems, maybe from Instana, where alerts are created on specific incidents where specific metrics are broken. And that is coming as alerts into the event manager. And the event manager is there for reducing noise and incidents with AI and machine learning capabilities. That means within the event manager, it's bringing together everything it's bringing together the event correlation. We organize the incidents in groups, and therefore we reduce for you as the user the work on bringing your own knowledge to grouping it manually and to look through the different incidents and grouping it manually. So within the event manager, it's really on noise reduction and grouping the incident. The event manager cannot only group the different events coming in from the different systems based on, for example, specific event analytics. It can also group that on the basis of specific scope, or it can be grouped on the basis of different topologies. Coming to that later on. Good thing is that within the event manager, all the events can be a part of the different groups, and you all see this different groupings and where this comes from within the capabilities of the event manager. Topology was one, or topology-based grouping was one thing that we can base the event grouping on, and that is the task of the topology manager. Give us the capability of bringing in the topologies. It could be that you bring in static topology, but we can also dynamically discover topologies. For example, like Instana does that in real time, so that you can really see what is the actual topology that I have, where is the problem, what are the surrounding services, and you can go back in time. So what was the topology when the conditions was good or bad? So you can really go back in time and have a look at the topology at different times. And then all together, you can really analyze with the topology-based event analytics, with the correlation of all the events that has happened, where was really the problem. And then you see it already here in the down left corner where the events are. There's this notion of runbooks. And that is the next aspect of the Cloud Pak for Watson AIOps. In the end, you also want to have the incidents, the alerts that you see, the issues that you have. You want to have them resolved. And that is where the runbook automation comes into the play. That means everything that has been detected, that has been analyzed, can be cured with a runbook that can be associated with the different issues, and it will be presented to you through the event manager what is the runbook that is fitting to this event. And you can, if it's a proven runbook that has been manually run in the past, you can also make the decision to let them automatically run and resolve the problem automatically. One word in the end about the AI manager itself. I have said it in the beginning, that's the kind of the brain of the Cloud Pak for Watson AIOps. We have talked about the data incoming managers, the event manager, the metrics manager, and topology manager. And then the AI manager is working with our patented and innovative AI capabilities that we see here for the 5 different use cases, and it's working on all this data. So that means we have the log anomaly detection. The AI manager is going to the logs, understands that with natural language understanding. That's also the case in issue similarity and the change risk assessment. We understand the texture concepts within the logs and the structured and the unstructured data from tickets. The AI manager is really identifying which of these assets belong together, which of the tickets belong together, and it's used for grouping the different log assets or the log entries together if they belong to specific incidents and need not to create a new issue or a new incident. Then we have the entity linking or grouping all the events and alerts together. So and understanding what really belongs to this specific incident, to this story, how we call it within the representation of everything that has been detected. When the AI is then really deciding it has to be created for a new story or belongs to an already existing story. It also detects the fault localization and blast radius. So what services in the surrounding area are affected or could be affected on that, what is really the cause of the problem, and what are the surrounding services that could be affected. This is what the AI manager does. This is what we have put into our brain of the Cloud Pack for Watson AIOps. When we look in the end at the different topologies that we can use for layout for Watson AIOps, we can install that on premises for sure in your environment. We can do this all on the cloud, on the IBM cloud, or we can do it and set up in a hybrid way. How we do that? With most of the IBM software, we install everything on a single OpenShift cluster. So all the components can run on OpenShift and can be installed in an existing OpenShift cluster or in an OpenShift cluster that can be installed in the context of the Cloud Pack for Watson AIOps. Here you see a layout where this is done in a single OpenShift cluster with surrounding data sources running in your own data center. If you have already existing infrastructure nodes with existing components running, or you do not want to have everything in a single OpenShift cluster, then we have this hybrid architecture. The main thing, the Watson AI Manager, needs to be installed on an OpenShift cluster, but you can run, for example, existing tools like Netcool, the Event Manager, outside of the OpenShift cluster, uncontainerized environment. So these are the deployment options of the Cloud Pack for Watson AIOps. Let me wrap it up again with this slide. And I hope in the end that we have seen that how Instana, Turbonomic, and Watson AIOps really gives you the ability to assure your application's performance, to really assure that your application is all the time up and running. And if it is not, how we can resolve issues with the help of artificial intelligence, with Watson AIOps, together with the help of Turbonomic and Instana to get it up and running again. Thank you for listening from my side, and for the closing words, back to Fred.
Sure. Thank you so much, Frank, Peter, Henning. That was really, really cool call today. And I really loved listening to you, and it was really nice to see how all these different pieces work together like a whole tool chain, and it was really cool. Maybe we go a little bit more into details in a different video, something like an Instana video, a Turbo video, or a Cloud Pack for Watson AIOps, something like that. If you do have any suggestions, what we should bring, what you're interested in, please drop us an email, give us any kind of notice. These kind of videos are pretty easy to produce for us. And as you know, we are going to publish them on YouTube. And with that, I'd like to thank you for your attention today. Thank you for your contribution here today, Frank, Peter, Henning. Thank you so much, and see you another time. Bye.
Thank you. Bye-bye.